Everybody for coming back for the near the final leg of the long day. It's great to see so many people hang in. Thank you very much. Okay, it's my great pleasure, again, an honor to introduce Professor Lisa Miracchi, who is a person who works simultaneously in philosophy and AI and cognitive sciences at the same time. She's a recent inductee into the GRASP lab. She's a new GRASP affiliate, so we're delighted to have you join us in that capacity as well. Lisa, thank you so much for agreeing to participate in the symposium today, and looking forward to your discussion.
Great, thanks so much, Dan, and thanks, Dan and Mike, for the invitation. This has already been a really fantastic symposium, and I've learned a lot already. And so I'm also very grateful to the speakers already, and I'm excited for the panel discussion as we continue the day. So as Dan mentioned, my previous work is primarily in philosophy of mind and cognitive science and artificial intelligence. So I have been focused on studying the nature of intelligence in both biological and artificial systems. And I think that genuinely intelligent systems, which include humans, but also many non-human animals, are very different from the current AI and robotic systems that we have. I don't think there's any in-principle barrier to building AI and robotic systems, but I think it's really important to emphasize the differences from a merely sort of intellectual, practical perspective. I think we'll build better systems when we acknowledge these differences. But I have also recently started thinking about the ethical importance of distinguishing between AI and robotic systems, and especially human decision-making systems and human agency. And so this is some new thoughts about this, and I'm really excited to discuss with all of you. But I think the place that I'm coming at this set of issues around autonomous weapon systems from is how do we, what ethical importance, what are the ethical issues when AI and robotic systems are really different from human decision makers, and how does that change how we think about some of the ethical issues? One thing which I won't talk about very much, although Mark mentioned it earlier today, and I think it's hugely important, is how do we train our students? How do we think about the obligations that we have in training our students? And I think some of what I have here to say today will be relevant, but I hope we pick that up again in the panel discussion. Another issue Mark brought up that I think is really important, that I will return to later in the talk, is how we think about talking about our work to a public audience. So I think the discussions about AI and robotic systems as making decisions, as learning, as being intelligent, as perceiving in a similar sense to the way that humans and non-human animals do. I think that although that is catchy and there are systemic industrial reasons for why we promote our work in this way, I think the flip side of it is the way some of these discussions get framed in autonomous weapon systems. So I want to flag those two issues as issues that are sort of on the periphery of what I want to talk about today. What I want to focus on is this issue of meaningful human control, which has come up comes up a lot in the literature. I'm just going to try to, there we go, okay. So this concept of meaningful human control was first introduced in 2013 by a UK-based NGO to talk about the ethical issues concerning autonomous weapon systems. And they write, deploying autonomous weapon systems that operate outside of meaningful human control is neither ethically nor legally acceptable, right? The key, right, here's the catch, everyone agrees on the first sentence. The key is how to explain how this human control is understood and to delineate the nature of human control that must be present in any individual attack. And so this is the question that I want to focus on for the discussion today, is how to think about what meaningful human control is when autonomous systems are different from genuine human decision makers. So it's really interesting digging into this literature a little bit in advance of this symposium. There's very little agreement about not just what meaningful human control might be, but how even to think about the issue and how to think about meaningful human control for autonomous weapon systems versus other kinds of systems that we have. And there's this really excellent paper by Mike Horowitz and Paul Scharr about meaningful human control. And I recommend it to anybody who's been, who's sort of digging into this literature. And one of the things they point out is that for many military operations regularly use sensors and computer processors to give humans information. And then computers are, processing is useful in guiding missiles onto the target or something like that. And so we are already using computational AI tools to help us both filter the information that we need to make decisions and also to execute those decisions. And so we don't want an account of meaningful human control that is going to interfere with or interfere with current systems that we think at least don't raise distinctive problems of meaningful human control. You might think that we shouldn't use these weapons for other reasons, but if you think that these systems don't raise issues of meaningful human control, then the question is how the use of computational power in these kinds of cases might differ from computational power in autonomous weapon systems. Okay. So there are a few really basic points to make, but I think they're important. So if you just think about the technology of a bow and arrow, right? That is assumed to be under meaningful human control, but it's not infallible. You don't have total information, and you don't have the ability to abort throughout, right? So when you release the arrow is gone, and you have no ability to abort, even if you afterwards acquire information that would lead you to change your decisions. So if the use of bow and arrow is under meaningful human control, then meaningful human control cannot require either total information, infallibility, or the ability to abort. And all of these things are, especially the ability to abort, has been something that has come up with the issue of meaningful human control. So that's a way of raising the issues that I'll be concerned with. My plan for this short talk is to explain some perspectives on how people are currently thinking about meaningful human control for autonomous weapon systems. Then I'm going to argue for, definition is probably too strong, but recommendations on how to think about meaningful human control that focuses on delineating the objects and bounds of permissible uncertainty. So I think by focusing on permissible uncertainty, we can make some progress on understanding what meaningful human control might amount to. I'm going to motivate a kind of general criteria approach as opposed to some of the specific control protocols that some other people advocate for. These kind of general criteria are going to help us understand in context what we should be looking for. A focus on permissible uncertainty, I think, motivates an integrated development of control protocols by both roboticists and ethicists and legal and policy experts. So this is something that I think is of interest to this group in thinking about what is the role of roboticists here. I think we want conceptualizations of these ethical problems that help us see how roboticists can bring things to the table and how to integrate insights and knowledge from roboticists with other experts to make progress on these issues. And lastly, and this will connect a little bit with some of Jessa Lingel's talk, I want to illustrate some of the difficulties of this problem by drawing on some of the global feminist literature. So I'm going to have a kind of positive view on this, but I want us to acknowledge the extent of the difficulties and subtlety here, but I'm going to motivate a kind of contextualized ethical approach to thinking about permissible uncertainty. Okay. So our question then is sort of which human protocols or what kind of human control allows for meaningful human control. So there are sort of two big strategies for answering this question that I want to differentiate. So one is to specify specific control features of permissible autonomous weapon systems or of the human autonomous weapon system arrangement considered as a human robot interaction system. So you might say, well, certain kinds of decisions can be left to machines and other kinds must be made by humans. You might have a kind of uniform approach where you say for all autonomous weapon systems, these are the kinds of autonomy that we can grant to machines, and these are the kinds that we can't. Or you might have a kind of differentiated policy. So you might say for certain kinds of autonomous weapon systems, they can have certain degrees of autonomy, whereas for other kinds they can't. So for example, you might say that the autonomous weapon system should have sort of be allowed to choose the selection of possible targets, but then a human must make the choice among those targets about which one to engage. That's the sort of first approach, and it's taken up by Daniele Amoroso and Guglielmo Tamburini in a 2020 paper of theirs, and I'm taking their taxonomy here. Or you might specify general criteria that a human control protocol would need to meet independently of the particulars of the autonomous weapon system or human autonomous weapon system. And I think that the second approach is a preferable approach. But first, let's talk a little bit about the specific control feature approach. So Amoroso and Tamburini take the sort of levels of autonomy from Noel-Sharkey. So you can think about it as sort of level 1 of autonomy is having a human engaging with and selecting targets and initiating any attack. That's very little machine autonomy. Level 2 is that the program suggests alternative targets and a human chooses which to attack. Level 3, a program selects targets and a human must approve before the attack. Level 4, a program selects and engages targets, but is supervised by a human who retains the power to override its choices and abort the attack. Level 5 is a program selects targets and initiates attack on the basis of the mission goals as defined at the planning activation stage without further human involvement. Okay. So Amoroso and Tamburini argue for what they call a differentiated control approach, where they argue that by default, we should stick to L1 and L2. We should stick to the lower levels of autonomy. And maybe there can be exceptions in certain specific contexts, but we should try and limit the autonomy of systems, machine systems to L1 and L2. So they think that meaningful human control requires delimiting the autonomy of machine systems. Now, I think that a general criteria approach is much better. So, for example, let's see. For example, you might think, let's see. Yeah. So, for example, even with L1 and L2, we can ask questions that I think are really important. So how might the bias for selection of certain, even the suggested targets, how might the autonomous weapon system bias for certain errors or against the selection of certain kinds of legitimate targets? That is uncertainty about the system that I think would need to be resolved before you would want to say that it's ethically okay for the system to suggest alternative targets to you. So as a kind of analogy here, it might be, this might be familiar to you. There's a current debate about what to do about the racist implications of a lot of face recognition software. So this is from work primarily of Bulamini and Jebru, who argue that because a lot of face recognition software gets trained on primarily white and male faces, it is systematically biased to have more errors for women faces and black faces, and especially black women faces, right? And so we haven't eliminated the ethical concerns just by saying the autonomous weapon system gets to select the targets. There isn't something, I think, important about, or something inherently, it doesn't make the system necessarily more ethical just because you have a human in there who gets to select among the targets. If the way that the targets are selected is not done permissibly, then the fact that you have a human in there won't make it a permissible function. So I think there are questions that arise at every level of this sort of levels of autonomy picture that we need to pay attention to. The second issue is, as I mentioned, the ability to say abort or something like that may or may not be important depending on what you know about the system. So the need to abort seems to be really important if you think that there might be really important information that comes in that you're unaware of. So I think a kind of approach that looks at these levels of autonomy and says, let's just pick the most conservative ones and make exceptions for the other ones, is missing out on some of the deeper ethical issues that are at stake. So I'm going to suggest that we take a kind of general criteria approach, which allows us to do several things. So one thing that it allows us to do that I think is important is that it allows us to treat the ethics of autonomous weapon systems as continuous with that of other weapons. So I think, as I mentioned at the beginning of my talk, I think it's really important that we do not frame the issues in terms of what decisions we let the machines make versus what ones we keep for ourselves, because machines don't make decisions. Rather, we should frame the issue in terms of how do we constrain the uncertainty around these tools so that the decisions that humans make are responsible. So I'm going to repeat that again. Rather than framing the issue about what decisions we let machines make, we should frame the issue around what information do we need in order for humans to be making responsible decisions. Okay. So here I have a quote from some people who are anti the legitimacy of autonomous weapons systems. And I'm going to read this out because there are two elements of it that I think are important for our discussion. So one is, so I'll just read it out and then I'll pull these out. So treating a human as an object is what happens when lethal autonomous weapon systems are allowed to kill. The victim, be she combatant or civilian, is reduced to a data point in an automated killing machinery that has no conception of what it means to take a human life. So some of the opposition here is coming from the idea that we're punting decisions to these machines that don't understand what they're doing. I'm going to grant that the machines don't understand what they're doing. I think I can give a kind of theoretical motivation for that view. But that doesn't necessarily mean that we're merely treating the human as an object or treating the human as a mere data point. I'll return to how we might think about that in a minute. But when we reframe it from punting over these decisions to machines that have no conception of what it means to take a human life towards what do we need to do to make the human decisions responsible, then I think we make some progress. The second reason for why I think we should go for a general approach is that we want to develop ethical guidelines that apply even as technology changes and develops. So to have your account of meaningful human control dependent on particularities of the autonomous weapon system, I think misses an opportunity to do something that's more general and long-lasting. Okay. So here again, I will take some insight from this great paper by Horowitz and Shar, who clarify the concept of meaningful human control as having 3 essential components. So they think human operators need to be making informed, conscious decisions about the use of weapons. Human operators have sufficient information to ensure the lawfulness of the action they're taking, given what they know about the target, the weapon, and the context for action. And the weapon is designed and tested, and human operators are properly trained to ensure effective control over the use of the weapon. Now, what I want to point out about this, this account of meaningful human control is that all of these conditions are crucially epistemic. Okay, so the humans need to be informed, the human operators need to have sufficient information, the weapons need to be tested so that we know the conditions under which they'll work or they won't work. We need to reduce uncertainty about the control of such systems and so on. So I really think that reframing the debate about meaningful human control as that of eliminating impermissible and uncertainty allows us to capture and generalize what Horowitz and Shah are after, and also to get more detailed in thinking about how these systems actually work and what kinds of uncertainty might be permissible and what kinds might be impermissible. So in something like a military context, there will always be uncertainty, right? In the use of any kind of weapon, there will always be uncertainty. In the use of a bow and arrow, there is uncertainty. But that uncertainty might be small enough that it is considered permissible, or the uncertainty might be constrained in certain kinds of ways. The subject of uncertainty might not be as ethically important as other kinds of uncertainty. So, for example, when we think about SARMOs, which sense and react to military objects, those are automated systems that are in use already. And one of the reasons why they're in use is that they have a very low risk of killing humans, right? The intention is to react to military objects. So it's not that there's very little uncertainty, but the object of uncertainty is not as ethically important, right? So my suggestion is that we really, as a group, and this is really sort of hopefully the beginning of a conversation, not an actual approach, but the suggestion is that we really think through issues of what is permissible uncertainty and what is impermissible uncertainty. And there I think roboticists have a huge role to play in the discussion. So one way of thinking through this is that we can think of a kind of back and forth between roboticists on the one hand and ethicists and legal and policy experts on the other, in terms of the ethicists and legal and policy experts can help us to raise and refine certain kinds of uncertainty questions, which roboticists can then help us provide concrete grounds for justifying or denying certain kinds of claims about meaningful human control, and give us objective grounds for comparing between weapon systems. So, and this isn't meant to be sort of a one-time thing, but rather a back and forth through the development of these systems and the development of policies around these systems. Okay, so in the couple minutes that I have left, I want to raise some questions about some of the weeds that we might get into when we're thinking about things in terms of meaningful human control, in terms of control that allows for only permissible uncertainty. And the sort of example I want to raise is that there's likely to be significant variation in what kinds of uncertainty are thought to be permissible or impermissible. So for example, the kind of uncertainty, so if you have meaningful, so from what I've said so far, if you go to the level 5 of autonomous weapons systems, where you have a system that is selecting and engaging and carrying out engagement with a target without intervention by humans, or perhaps without even the ability for intervention by humans. If you can eliminate all the impermissible uncertainty, my suggestion is that at least that system is under meaningful human control. What would it mean to eliminate the impermissible uncertainty there? Well, I think that a nice way of thinking about it is in terms of de dicto versus de re decision making. So, I'm a philosopher. I can't make it through a talk without throwing a little Latin at you. But the basic idea is that what we should think about for, say, a level 5 autonomous weapon system is that we have eliminated all the uncertainty such that we know that the system will act the way we want it to act in certain kinds of situations. So although we haven't picked out a particular target as that target, we have described the target in the ethically relevant way, and we know that the system is going to behave as we prescribe. Now, you might think that that's not enough. You might think that the kind of uncertainty that needs to be eliminated is, you might think that the kind of certainty we need is knowing that that target is the right target, where it's a kind of de re, you've picked out a particular target. And that's not something a level 5 system will ever allow a human to decide, because the human from the get-go is saying these kinds of situations are permissible and these kinds are not. They're not picking out particular targets. So this is the kind of consideration that I think the Rosart and Sauer quote points to. So this is the other aspect of this quote that I wanted to draw out. So they say, treating a human as an object is what happens when lethal autonomous weapons are allowed to kill. The victim, be she combatant or civilian, is reduced to a data point in an automated killing machinery, blah, 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 blah. Okay. So one way of reading what they're saying here is an interesting point that should be taken seriously. Namely, do you need de re reduction of uncertainty, knowing that that target is the right target? Or is de dicto reduction of uncertainty enough? Is it enough to sort of have data, have general information about your targets to know that that target is an ethical target? And I'm just going to raise that as a question. I think that that's a really interesting ethical question in this arena that we can divorce from concerns about killer robots or anything like that. Okay, the very last thing I want to say, because I'm running out of time, is that one way of thinking through these issues, I'm going to draw on from Serene Cotter, who is a ethical and political philosopher who I highly recommend. And I'm going to add to Jessa Lingel's reading list that she gave us for today, Serene Cotter's book, Decolonizing Universalism, which I think is a truly excellent book. And what she's grappling with in this book is, how do you have universal ethical values without imposing an imperialist Western perspective? How do you say something like, sexist oppression is wrong without imposing things like we should be secular, or women should not wear head coverings, or things like that? So that's the issue that she grapples with in her book. And what she writes is, you can think about feminism as a kind of universal opposition to sexist oppression, but what sexist oppression looks like is going to differ from context to context. You have to look at the specific context on the ground to see what would actually help women in that context. And let's not assume that what works in the US or what works for us with our background is going to work in this other kind of context. So analogously, we might say the following. We might say that the ethical use of autonomous weapon systems requires meaningful human control, which requires the elimination of impermissible uncertainty. But it does not require universal adoption of Western values about what kinds of uncertainty are impermissible, or particular strategies for eliminating that uncertainty. So those are issues that might be specific to autonomous weapon systems and might need to be carried out in the specific context in which those weapons might tend to be deployed. So that's a way of saying that we can frame international discussions about meaningful human control in mutually respectful ways, centering on a common goal, eliminating impermissible uncertainty, and working towards perhaps mutually acceptable standards or something like that without imposing our conceptions on others. Okay, I'm out of time. So I'm just going to briefly summarize what I've done today. I've suggested that we should refine our language and incent. Oh, I haven't really talked too much about this, but about the incentives part. But I think we should refine our language to refocus from machine decision making towards human decisions that can be responsibly executed. I think we should take a general criteria approach to control strategies to clarify what meaningful human control is. I've suggested that these criteria are well organized in terms of thinking about eliminating impermissible uncertainty. I've suggested that this helps us think about how questions of uncertainty and resolving them require the integration of efforts from both roboticists and policy experts. And lastly, I've suggested that adopting a kind of global feminist perspective helps us understand what a kind of responsible discussions of these might look like. So we can retain the kind of generality of the ethical project without imposing Western values unduly. Okay, thank you so much. And I look forward to questions if we have time.
Lisa, thank you for this penetrating and exquisitely precise talk. The penalty is unfortunately that we're out of time for questions now, but I trust that people will have many, many for you when we resume in the panel. It was terrific. Thank you so much for this really powerful, persuasive lesson, for me at least. Thank you. We'll return. We're not done with you, but we'll come back. Okay, folks, thanks for those of you who. Oh, good. We're almost at our morning attendance. We're doing fine. I have the honor to bring up the rear here. I'm going to have a much narrower presentation that I hope will cue us up for the panel, for the more perhaps specific actionable directions that the end of the day and the beginning of the next part of the conversations might bring up. So let me start here. And Mark, I think that you can be guaranteed, if I should be so indiscreet as to run over, you'll kick me in the shins and stop me. Yeah, okay, thank you very much. Okay, so I'll share my screen. And hopefully you can see. Can you see my PowerPoint projection?
Yeah, that's good.
Okay. Okay. So let me just put my timer on here. So I'm very concerned both with the pedagogy and the practice of ethics in general in robotics, but particularly these days with the implications, social implications of our military applications. I'm going to spend most of the talk discussing the efforts, I think impressive efforts to date, that a group of engineers has made at a disciplinary level, not as opposed to, but as distinct from the more ad hoc or NGO level, very useful and good introductions of debates. But the IEEE has issued, not the IEEE has published a book called Ethically Aligned Design. The first edition came out in 2019, and its guidance for consideration expressed by the Global Initiative on Ethics of Autonomous and Intelligent Systems, a mouthful, which turns out to be a collaboration of more than 1,000 academic, industrial, and government participants. Importantly, not recognized by the IEEE. What's the IEEE? For those of you who don't know, we believe that the IEEE, with nearly 500,000 engineers around the world, is the world's largest technical professional organization. And they're very, very careful to distinguish between their publications, which they support, and their policies, which are much more elaborate, as I'll describe. This document I find quite impressive. It was prepared in what they call an open collaborative consensus building approach. Their deliberative emphasis gave them numbers of iterations. They started this effort in 2016 and only published this first edition in 2019 after posting and critiquing and vetting and circulating, adapting and iterating on 2 prior versions. Okay, and if you read these documents, particularly the last one, the first edition, the last one they're really making an effort, I think an impressive and difficult effort to integrate diverse perspectives and expertise, including a sincere effort to introduce bilingual and multicultural perspectives, addressing some of the points that Lisa was making in her previous talk. And moreover, they're not only recognizing the difference in language and cultural traditions, they're recognizing and trying to address the nature of technical dialect. So for example, they have a glossary with many, 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 many words translated into the language of, computer science, the language of engineering, the language of government policy. This glossary alone, I think, is quite interesting. I would recommend it to you. All right, so that's what I'm going to spend most of my time talking about. I'd like to thank Jessa Lingo for reminding me, urging me to give a larger context for those of you who may not be roboticists and may not even be engineers, since we want to have a very broad multidisciplinary discussion. She urged me to say a little bit about the nature of robotics research, the nature of my research, the nature of my funding, and what the implications of my funding may mean for my conflicts of interest. And so thank you very much, Jessa, for urging me to do this. My lab focuses on the synthetic science of robotics. This is work by Turner Topping, who's going to be graduating pretty soon, where his robot leaps up, grabs the door handle, and walks through the door. Okay, we can talk more about the robot capabilities later. I'm trying to give you a sense of the kinds of groups that you'll see in the GRASP lab and similar groups across the country. I would say my group is relatively typical. I have 4 postdoctoral scholars right now, 8 PhD students, numbers of younger students. The theses of the PhD students to come and the postdocs already in my lab are quite diverse. Robotics is very diverse. We have engineering theses, computer science theses, math, biology. I have a wonderful young postdoc who's a paleontologist. And of course, we have very, very broad and diverse collaborations with professors and thinkers. And for me, it spans biology, geology, math, and a little bit we're beginning to dabble with help from people like Lisa into the world of philosophy. Jessa thought it was very important for me to describe the nature of the funding, which I think is very good advice. Over about 40 years, I have won about $45 million in 30 or so grants, of which I'm the principal investigator. Importantly for the audience, whereas a large majority of these grants have been from National Science Foundation, the preponderance of the funding in my group over the years has come from the smaller number of DoD grants. And you can see the disproportionate nature of the funding, okay? I have to stress that universities such as University of Pennsylvania, any of our peer institutions permit only unclassified work and unrestricted publication, and of course, unrestricted teaching. However, independent of the funding source, so there's no restriction due to the funding source. However, it could be that many US citizens are not aware of the increasing encroachments by such apparently innocent regulators as Department of Commerce on the nature of our international communications. I am not permitted to communicate details of technical work in my lab to non-Penn or non-US citizens unless they have appeared in the open literature. There are some more restrictive constraints on communications, again, completely unrelated to funding, that come out of the Department of State, but I can't say that I've run into any of them in my work, okay? So thank you, Jessa, for urging me to present this context. I hope this is useful to those of you. I would say this is a pretty typical profile. Everyone's a little bit different. I have probably less industrial funding than many of my colleagues, but this is a typical profile, I would say. Okay, let's get back to this ethically aligned design report. It's based upon, they articulate certain overarching principles that I think we've heard a lot about today. You know, artifacts are supposed to promote human rights and well-being. They're supposed to enhance human agency, and they're supposed to reflect and promote a global ethical human wisdom. Designers have responsibilities that include making the technology transparent, that is, its decisions or its consequences should be explainable, and there should be an accountability trail. That is, there should be an apportioned provenance with attribution and liability and culpability clearly explained. The designers have the responsibility to provide evidence of efficacy, and the designers have the obligation to provide potential users or operators with a clear statement of what the competence is required to use these tools. And they're obligated to introduce guardrails against misuse. The report itself has already had, I think, useful impact. There are now standards committees working on trying to take some of these ideas into the real world. There are courses that are developing on the IEEE website. There are technology certification protocols. There are increasing scoped forums and things like an AI Commons that they've developed. And what I want to stress is that this is a disciplinary, this is the IEEE, which again is the professional organization. By no means a perfect organization, but it is the expression of a variety of engineering disciplines. I'm going to run out. I can see I'm already running out of time, so I think what I'll do is they try to provide guidelines. They make clear in this document that ethics must be part of core education, being taught by not just engineers who have read the ethics literature, but taught by outside experts. There is supposed to be an exposure to cultural variability and norms, and a clear exposure to the process of developing ethical standards. They have guidelines for corporate practice that include the obligations on the corporate leaders and the requirement to empower whistleblowing from bottom up and things like that, and the necessity of having external oversight and clear certification standards. They grapple with, and by no means an answer, what it means to embed values. First of all, whose values, where do they come from? Well, it's a normative story. Local communities' values. Of course, they recognize that such values change over time, and such values have intrinsic conflicts, and there are conflicts between local communities often. They also understand that they don't pretend that we have anything like an effective computational representation for Asimov's laws, for example, right? And another challenge, of course, is graceful failure. We've talked a little bit about that, and that featured in Lisa's talk. Very important to introduce in this document. They introduce the importance of evaluation mechanisms, bias identification, and the access to the ability for third parties, independent parties, to validate. They urge certain approaches to policy and law. They urge that the designers be mandated to promote internationally recognized legal norms. They urge that designers, the engineers, the roboticists focus on new research that would address these challenges, particularly the challenges of embedding ethics, values. We can debate the wisdom of this, but they come out loud and clear about that. And the mandate for the engineers to educate governments and public appropriately. They also cover the prospect of mandates to design to the users themselves, we can talk more about that as the discussion section goes on. Interestingly, they've spent some time urging government and policy organizations to deny personhood. The Saudis declared that a certain robot had citizenship at a certain point, I think 3 or 4 years ago. What you won't see, importantly, in this EAD is anything specific to lethal autonomous weapon systems. There was a chapter in version 2, but there is no chapter in the first edition. I'm again, in the interest of time, I'm not going to talk too much about what was there and what was omitted, but it was a narrow but useful discussion, some of which we've rehearsed today. The common points, I think, are that they emphasize, as most of our speakers today have, the importance of transparent and explainable technology. This is particularly challenged by, for example, as CJ pointed out, the advent of data-driven rather than necessarily representational components. And it makes it even harder to come up with predictable behaviors. The accountability and the controlled deployment are crucial. There must be identifiable, responsible human operators. Again, CJ touched on this quite ably, I think, by talking about the need to develop standards of provenance in the design of technology. Who's responsible? How was it developed? What were the tools of development? Audit trails to document the provenance. So these are issues that the engineers are starting to grapple with. Designers themselves need be informed. They need to understand the social implications of their work. They should have the understanding of the need to develop and actively maintain professional ethical codes, and to understand international and local law. So there are lots and lots of problems with the statements that you'll see in this version 2, and they recognize some of the issues and don't recognize some of the others. I'll run through them quickly before I get to where I hope our symposium will get to in the panel discussion and beyond. Everybody understands that there's a huge confusion of definitions. Most of us are now willing to admit that we don't understand what the word autonomy means, although some people still think they do. Even such distinctions as human in, on the loop turn out to be vague, inadequate relative to emerging technologies. It's well understood, I think, certainly in these early parts of the document, that the absence of professional codes of ethics is problematic and needs to be addressed. Designers, as has been said by several different people in today's symposium, it's clear that designers have ethical obligations beyond legal requirements and beyond the requirements of simply ordinary citizens. The professional organizations understand that they have the obligation to offer practical resources and advice to individual designers. So a different set of challenges that they identify is that we engineers in general don't have a good understanding of the socio-political context and what aspects of technology are destabilizing or escalating, or to the contrary. We understand that human control is, of course, eroded by the shrinking time constants. At deploy time, we also understand that there can be more stabilizing or less stabilizing technologies. And then at design time, we understand, of course, that any conventions that we adopt are liable to be thwarted. They're liable to be compromised by accident or by malicious design. It's very easy for individuals to abuse these technologies, and some argue that the military robotics are intrinsically, are mala in se, are wrong in and of themselves. It's all too easy to see that local inappropriate use by domestic police or security forces is already a problem, and the availability to and the proliferation by non-state actors globally has been remarked upon many times already in our symposium. I will spare you the technical challenges, which, well, these are very complex systems, and complex systems are very hard to design, much less understand, and prone to unforeseen scaling effects. The adaptive nature of the new data-driven algorithms makes these problems harder. I have personal, opinions about this, but let's not spend too much time. So let me close. I'll take another, 2-3 minutes, and then I'll welcome questions and discussion. The question before us today, and I hope will be the focus of the panel discussion, and I hope many of you will be willing to not just take our survey, but to sign up to work with us on following activities. The question is, what are the ingredients of, and what is the road to ethically aligned military robotics? it's not as though we don't have positions staked out already, right? You've heard reference many, many times today to the DoD Directive 3000.09, and that's been repeated. I won't bother. They define effectively what they mean in a very general sense, and they state again very generally, but I think usefully, what's required of such systems, what would be required of such systems. Mike covered this with much greater care than much greater expertise than I'm able to, but my understanding is that we have various NGOs that have staked out positions that, for the most part, propose to ban the development of such lethal autonomous weapons. My understanding is that some nation states, notably China, have proposed to ban deployment, but explicitly not research and development. And my understanding is that the United States, also Russia and other nations, does not support a ban on research, development, or deployment of lethal autonomous weapon systems. And I understand this is a shifting ground, and I may not be reading the articles correctly. I will welcome being corrected on these. What could be the next steps of interdisciplinary groups like this one? I don't know if everybody was I felt that we had a wonderfully good and important day listening to this broad set of perspectives, disciplinary perspectives within, but notably outside of engineering. What would be the next steps? It seems clear that international engagement is crucial. My understanding, reading recent literature and talking to colleagues, is that the world government negotiations like this CCW that Mike mentioned and groups of government experts seem to be stalling a little bit. And so the urgent question for us as roboticists is, what can we do to help? What insights or what technical information or concepts can we offer to the governments or their agents? So the to-do here for a group like this, follow one, would be to carefully identify concepts and terminology, as well as emerging capabilities that are in need of definitions, and importantly, when you're talking about it, IEEE standards, okay? On the inside, it's clear that robotics as a discipline needs to mature, so that, as has been said a couple times, a couple different ways by earlier speakers, the designer's obligations expand, right, in step with the efficacy and utility of their designs. So what is it that roboticists might ask for and might get from such distinguished thinkers and the students of such distinguished thinkers as we've heard today toward meeting these obligations? So here I think the to-do is to identify concepts in literature, which we've begun to do today, needed not just to define, but to codify. That's the obligation, it seems to me, to codify roboticists' ethical education and guidelines. So this is not a one-time effort. This is nothing that's going to get done in one afternoon or even 1 year. The notion that my colleagues and I on the GRASP faculty have is that a panel discussion might hopefully begin to address such questions so that we're not just idly speculating. I'm hoping that you will take some care in this post-symposium survey, at least to tell us what we got wrong and what we got right in today's presentation. But possibly some of you would be willing to sign on to form future working groups. What would those working groups do? We're hoping, my colleagues in GRASP are hoping that we would try to disseminate and coordinate similar processes to this one across sister campuses for the coming year, and indeed engage the other important stakeholders that include industry and government, some of whom are here today listening. There is the biggest robot conference, International Conference on Robotics Automation, sponsored by IEEE, will be held in Philadelphia in the year 2022. That is next May. And the hope would be that we would have a much more comprehensive version of a workshop like this, where we're actually beginning to talk about things that could be codified and concepts, terminology that could be offered not on the basis of ad hoc individuals writing statements to the newspaper, not on the basis of NGOs, but on the basis of a disciplinary agreement, which will, again, because it's a large organization and these disciplines are far flung and international, will take more than 1 year to achieve. Okay, I'm stopping. I'm very grateful to the truly illustrious thinkers that we've seen present their work today across the many, many, many different disciplines. And I'm hoping that we'll launch this year-long and multi-year-long effort to actually get something done with the beginning of a panel discussion shortly. And I will happily take questions or comments.
Can you provide a bit more detail on the agreements that foreign countries had? Right, you flashed on your slide. There was agreements with China and Russia. Can you give a little
Yes, I can't. I mean, I've read, but I will refer you, and I hope that Mike will enlarge upon this in the discussion. Mike Horowitz is a world expert exactly in this domain, and I would rather that we get that information presented by somebody who's truly a disciplinary expert rather than my more amateurish reading of these statements. So if you don't mind, I'll deflect that question, but urge you to bring it to our panel at 4 p.m.
Understood. Thank you.
Thanks.
If I could ask a question, one of the ways that military technologies have become non-usable in the past has to do with they're not actually working. And there's kind of a story that says that AI doesn't really work that well, and these robots can barely open a door. They can't stack the toys in the video. And I mean, the reason that weapon systems begin to lose favor is often oriented around their failure to accomplish what states want. Can you just address, is that possible for robotics? Because admittedly, it seems as though you could reach a point where anything could be done in this way. But what is your take on that right now?
Yeah, it's a hugely important question, and it's actually quite controversial. I have a position in this which is considered to be somewhat extreme. Okay, and I can talk about my personal position, later in the panel. It has to do with proofs of correctness and things like that. But I would go back to a book by Herbert Simon, who wrote The Sciences of the Artificial. And CJ made this point out, a number of people have made this point eloquently, that what we understand is that if you want to understand a complex system, you must understand a triple of its architecture, its tasks, and its interface to its environment and what its environment is. And we do have disciplines in engineering and particularly in robotics for studying that triple. But that study requires a great deal of effort, which is made particularly difficult when the environments become less and less certain. Difficult doesn't mean impossible. My personal position is that it's incumbent upon the discipline to do this, which is what Herb Simon urged that we do 50 years ago, when he, at the point that he was getting his Nobel Prize. So yes, I don't think it's easy to do what you're proposing that we do, but we have methodologies for doing exactly that. And those methodologies all too often get cast aside because these tools, as you pointed out in your talk, they are shiny. They are really alluring and we want to use them, right? We're in a hurry and they seem to be very, very useful. In fact, they are very, very useful, except when it turns out that they're not, or that they're useful. So thank you. That's a really crucial question. And I think we're going to hopefully talk more about that as the afternoon finishes out. Thank you.
I had just one kind of follow-on comment, perhaps, to that one question, which I was just thinking about in combination with Lisa's talk previously, where she was a big part of the autonomy and, you know, those five levels and all that kind of stuff is the selection of the target. And, you know, your points about AI not working well, or Vijay's points about AI not working well in robotics a lot. He said, however, it is working well in the machine vision part, understanding what is a chair and what is a person, what is a static object and what is a person. So being able to select a person now suddenly becomes a lot more powerful in terms of engaging in, you know, weapon systems, potentially recognizing people.
You don't mind my putting an asterisk here. Let's not confuse the ability to recognize something that looks like the database that fits in the database of humans that I've exposed as distinct from the semantic and the abstract concept of a human. We don't even, part of the difficulty that we have in implementing Asimov's laws is that we don't have even a semantic, much less a conceptual representation of human, much less harm to humans.
But the technological ability for a machine to not shoot a chair or not shoot a person is now there, which wasn't, you know, 20 years ago, at least not as easy. Now you can get an Xbox Kinect, which recognizes a person for $100, which, you know,
chairs that we were thoughtful enough to train up on our databases will not be shot, right? I think I'm out of time. I think this session is now coming to a close.
Unless the person's sitting in the chair, Dan.
Okay, Fred, but you're going to come back in the afternoon. Okay, so folks, this is only the beginning. We're going to finish the beginning with one last hour with a panel that will be moderated by Professor Yim, director of the GRASP Lab, and Professor Horowitz, director of the Perry World House. Please return at 3:59, and we'll launch our large discussion. Thank you very much.